My name is Mark Amor Segan. I am Principal Research Engineer for the Energy Innovation Centre here at WMG, which is part of the University of Warwick, based in the UK. Our facilities here at the EIC are unrivaled across Europe in terms of the breadth and depth of capability that we have. We have some of the most state-of-the-art manufacturing, test and characterisation equipment. The Energy Innovation Centre is one of the few centres in the UK, if not Europe, where we can go from an experimental powder through experimental cell design into large format cell manufacturing, module and pack manufacturing, and then through ultimately into a complete electric powertrain. So WMG has a long history of working with our industrial partners to take good ideas from research and academia and deploy them successfully into an industrial application. WMG's Energy Innovation Centre is a one-stop shop for electrochemical or energy storage technology development. The three main drivers or focus for the research is performance, cost and safety. So those are the three aspects of the technologies that we are looking to improve upon over the next 4 to 5 years. The development process starts with us, if you like, recipe making. So we're developing our new chemistries for the new prototype cells. Once we've finished the chemical process, we start to build our prototype battery cells or battery packs. That production is performed in what's called a dry room. So it's an incredibly dry environment to protect the chemistries that we use. So one of our main laboratories is a dry room, which is where all the cell manufacturing takes place. Once the cell manufacturing has been completed, those cells will then transfer into our main battery testing and characterisation laboratory. So they're in very controlled conditions. We have a lot of thermal chambers, we have a lot of cell cycling equipment, and in that facility we will explore comprehensively the behaviour of those energy storage technologies. The aim is to understand comprehensively the behaviour of these energy storage technologies so that we can then ensure that when they're assembled into the final battery packs and go into their final industrial application, we have high confidence that they will succeed. As the performance of our energy storage technologies improves, what we're essentially doing is increasing the amount of energy and the power that these cells can deliver, which increases the hazards and the risks potentially of us working with those technologies if something was to go wrong. So one of the key changes over the next few years is the move towards what we call protected thermal chambers. So these are thermal or climatic chambers which have the necessary safety systems to ensure that our researchers and our engineers are kept safe if something were to happen to one of these technologies. WMG's Energy Innovation Centre has been in existence for just over 10 years now, but in the last 5 years it's evolved very, very rapidly as we've had investment from the UK government to become one of the UK's premier battery or energy storage research centres. I don't see that innovation and that evolution slowing down. If anything, it's increasing, and our capabilities are growing faster and faster and faster at the moment to keep up with the demand for electric vehicle technologies and energy storage in general.